Hello students, welcome to Power Classes. So today we are going to revise chapter 13, which is statistics. So in this chapter we have total 3 main topics, which is mean, mode and median. So today we are going to discuss about 2 topics, which is mean and mode, whereas the median will be covered in the next video. Okay, so let's see about what is mean. So mean is nothing but the average of all the values which was mentioned in any use case. So for the ungrouped data we have the direct formula, that is sigma fi xi by fi. For in this chapter we're going to discuss about grouped data. So for solving group data we have total 3 methods, which is direct method, assumed mean method and step deviation method. So let's see about the formulas now, and the examples I will explain using the exercise questions. Okay, so let's see what about direct method. So in the direct method it's we use generally for the smaller values. So here the formula is same with respect to ungrouped data, that is sigma fx by sigma fi, which is fi xi f1 x1 plus f2 x2 and so on, f1 xn by sigma fi, where xi is the average of the interval mentioned and fi is the respective frequency. Let's go for assumed mean method. So this method we use generally for the larger values, or else at least which are having more than 100 kind of thing. And for the assumed mean method the formula is x equal to a plus sigma fi dA by fi, where a is the assumed mean of the xi as above method, whereas di is the xi minus a for each interval. Okay, so what about the third method? Third method is called step deviation method. So generally we use this for larger values as also for the values where the frequency is not same. That is the intervals. For suppose the first case is 0 to 2, 2 to 4 and so on, and suddenly it increases 10 to 16. So in these cases step deviation method will have a lesser difference and it will be the actual value. So what is the step deviation method formula? X equal to a plus h into sigma fi ui by fi, where ui is xi minus h minus a by h, where h is the common divisor of all the xi minus a values. So let's see each example with respect to exercise questions. So from the exercise 13.1, in the first question can be solved using the direct methods. I'm using this as an example. So here you can see they have mentioned number of plants and houses. Number of plants are having exact interval like 0 to 2, 2 to 4 and so on. So each interval is having only 2 difference. So here we can't use standard deviation method because, as I mentioned, standard deviation we can use, but if it is for larger values then go for it. Whereas for assumed mean method also it is preferred for larger values, but this number of plants and frequencies are lesser, so directly we can use the direct method. That is the first method. So xi, as I mentioned, it is the average of the interval mentioned, that is 0 to 2 the average is 1, 2 to 4 the average is 3, 4 to 6 is 5, 7, 9, 11 and 13. So then we have to find fi xi values, that product of these two. 1 into 1 is 1, 2 into 3 is 6, 5, 35, 6 9 is 54, 2 9 is 22 and 3 13 is 39. After finding those values, we have to apply the formula and get the mean value. So as I mentioned, number of plants and houses are small here, so we can go with the direct method. So mean equal to summation of all these values, 1 plus 6 plus 5 plus 35 plus 54 plus 22 plus 39 by sigma all, which we have, which is 20. So just adding and by dividing we will get the 8.1 as the mean value. So in this way the direct method can be solved. Next, see another question which is of same exercise, fourth question. So here you can see the number of heartbeats are pretty high, like 65 to 68. So it is more than 50. So in this kind of scenario I suggest to go for the assumed mean method, because using assumed mean method we can solve it a bit faster compared to the direct method, as the calculation will be a bit high with respect to direct method. So here the frequencies we already have. So the xi is the mean of this interval, that is 65 to 68, the average will be 66.5. Same way here 68 to 71 it is 3, so just 1.5 the average, 68 by 1.5 69.5, 72.5, 75.5, 78.5, 81.5 and 84.5. So all the xi values are defined. So in this table you have to consider at least one as a value. So what I am saying is, we can, if we go 1 2 3 4 5 6 7 values are present, so we can say directly the middle value, that is 75.5 as the assumed, that is a value. Okay, so then we need to find the di. Di is nothing but xi minus a value. So a is, as I mentioned, we have 7, so I am taking this. If you have even number you can consider any of these two if it is even. If it is odd you can directly consider the middle value. Okay, so xi minus a, that is 7, xi is 66.5, 66.5 minus 75.5, which is 9, so minus 9. Here 69.5 minus 75.5 minus 6, 72.5 minus 75.5 minus 3. This is already same, so 0. 78.5 minus 75.5, that is 3. 81.5 minus 75.5, that is 6. 84.5 minus 75.5, it is 9. So then you can see here the values are pretty easy now instead of larger values. So that's why I suggest you to go for assumed method if it is having larger values. Now FIDA, that is frequency into the DA value. So 2 into minus 9 is minus 9, 18. 4 into minus 6, minus 24. 3 into 3, 9. 7 into 3, 21. 4 into 6, 24. 2 into 9 is 18. So just calculate the summation of all these values. 18 and 18 will get cancelled. 24, 24 will get cancelled. So 21 minus 9, which is 12. The same way sigma Fi, if you calculate, you will get 30. So let's go and apply the formula, that is using assumed mean method. The formula is A plus sigma FIDA by sigma Fi. A, as I mentioned, here I'm taking this value, so 75.5 plus sigma FIDA I will calculate it, which is 12 by sigma Fi is 30. So the final answer will be 75.5 plus 12 by 30. For 6 2s are 6 5s are, so 75.5 plus 2 by 5 is 0.4, so total answer is 75.9. So in this way you can find the mean value using assumed mean method. Let's see another example where we can use the third method. Okay, let's see the 7th question of the same exercise. So in this I am using the standard deviation method. So here they have mentioned concentration values, which is 0.00 to 0.04 and so on to 0.20 to 0.20 to 0.24. The frequencies are already mentioned, and as I mentioned, xi is nothing but the average of the interval mentioned, so it will be 0.02 for this case, 0.06, 8 to 12, so between will be 10, that is 0.10, 12 to 16, middle is 14, so 0.14, 0.18 and 0.22. Here first we need to assume one h value. H value is nothing but here you can see that everything is having decimal of 2 digits. So I'm assuming h value as 0.01 so that I can directly convert it to an integer while dividing. Okay, and here also 1 2 3 4 5 6 are present, so I can consider this or this, anything is fine, but for my convenience I'm taking this as a value, that is a value, similar to assumed method. So after that I need to divide with h, which is 0.01 I'm considering because everything is having here 2 decimals, so by dividing 0.01 will be easier for me to convert. So then you have to apply the formula, that is u equal to xi minus a by h. So 0.02 minus 0.10, that is 0.08 by 0.01, so it will be 8. So 0.08 by 0.01, cancelling we get 8 value. Thus similarly for this case it is 0.06 minus 0.10, that is 0.04 by 0.01. So again also this will get cancelled and the final value will be 4, that is minus 4, because 0.06 minus 0.10. The same way here it will be 0. Now here 0.14 minus 0.10, that is 0.04, 0.04 by 0.01, so it will be 4. The same way from here 0.18 minus 0.10, it will be so 0.08 by 0.01, which is 8. The same way here also it will be 12. So most of the cases it will be easy to identify because this, you can find the difference here. Eight to 4, and here it is again 4, 4, 4, 4. So you can also verify it while doing the sum. If it is somewhere it is not in order, then definitely somewhere you have made a mistake. So better you can also verify by using the same interval difference. Okay. So let's go with Fi Ui part. So here we have Fi, this is Ui. So 4 into minus 8 is minus 32. 4 into 9 into 4 is minus 36. 9 into 0, 0. 2 into 4 is 8. 4 into 8 is 32 and 2 into 12 is 24. So just add all these values. 32, 32 will be cancelled and 24, this will become 56. 56 and 8. Okay, let's cancel each other. 32 and 32 are gone. Minus 36 and this will become plus 32. So the final answer will become minus 4. So just we need to add all this, and here also just add all this, you get 30. So now using formula you have to find the mean value of the standard deviation method. So using as I mentioned, I just written in words as well that xi is in decimals, and taking common factor it will be easier to solve this type of question. So mean value will become a plus h into sigma fi ui by sigma fi. H I have already taken as 0.01, so a is 0.1 and 0.1 plus 0.01 into fi ui I got it as -4, so -4 by sigma fi is 30, so -4 by 30, so this will become 0.1 minus 0.04 by 3, which is 0.1 minus 0.00133, which will be closer to 0.099. So in this way, mean can be calculated with all three methods. So when and where to use the method, I will explain once again. That is, direct method can be used if these are sufficiently small. If they are large, you can go for any of the method, but assumed mean method it will be little easy. Whereas for standard deviation method, if it is decimals or two larger numbers, then go for the step deviation method. If they are not mentioned any method, then I suggest you go with, if the numbers are high, any of this method, numbers are small, you can go with this method. Okay, so let's go with the second one, which is mode. So what is mode? For suppose we have n number of values, and the mode will be the value which is having larger number of like most repeated value. For suppose for ungrouped data, if it is 1, 2, 3, 3, 3, 6 and 8, this type of data, what is the mode is 3 is the answer, because 3 is repeated more times. But here in this chapter, as I mentioned, we are calculating for grouped data. So for grouped data, we have only one formula for mode, which is this one. The formula is L plus f1 minus f0 by 2f1 minus f0 minus f2 into h. So what is L? L is the lower limit of the model class. H is the size of the class interval. F1 is the frequency of model class. F0 is frequency of preceding, whereas F0 is frequency of succeeding. So let's see with example. So here you have our family sizes 1, 2, 3, 3 to 5, 5 to 7, 7 to 9 and 9 to 11. Number of families I have mentioned. So which is having the larger value will be our model class. That is most repeated. Okay. So here 8 is our model class. L is the lower limit for this model class, which is 3. F1 is the one which is preceding this one. So F1 is 8. F0 is the preceding, that is 7. F2 is the succeeding, that is 2. Okay, so the formula as I have explained is L plus, so 3 plus F1 minus F0. F1 is 8, F0 is 7, so 8 minus 7 by 2 into F1, so 2 into 8, 16 minus F0 and F2, 7 and 2. So 3 plus 8 minus 7 by 16 minus 7 minus 2, and the H value is size of interval, that is 3 to 5, so that is size is 2. So 3 plus 8 minus 7 is 1 into 2, that is 16 minus 7 minus 2 will be 7. So 3 plus 2 by 7, which will become 3.286 is the mode of this question. So let's see with examples of the exercise. So in the exercise 13.2, I'm taking an example of second question. So here you can see they have mentioned lifetime and frequency of 1, 2, 3, 4, 5, 6 intervals. So 0 to 20, 20 to 40 and so on, and they have mentioned frequencies. The larger value, this one. So this will become our model class. So for the model class, we need to write the frequency and L values. So L value is the lowest here, that is 60. H is the difference, 60 to 80 is 20. F1 is this value, 61. F0 is before 1, 52. F2 is the after 1, 38. So we got the respective values. So just using the formula, we will calculate the mode value. So mode equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. L is 60 plus F1 61 minus F0 is 52 by 2 into 61 minus 52 minus 38 into 20. So just solve it. 60 plus 9 into, this is 9, so 9 into 20 by 2 into 61 is 122 minus this 2 will become 90. So 60 plus 180 by 32. So if you cancel, we'll get 45 by 8. So 45 by 8 is 5.65. So just substitute the value 60 plus 5.65. The final answer will become 65.65. So let's see another example. So in this question, they have mentioned runs scored and number of batsmen. So runs scored here till 3,000 to 4,000 and so on to 10,000 to 11,000 they have mentioned. Number of batsmen 4, 18, 9, 7, 6, 2, 3, 1, 1. The highest is 18. So this is our model class. So here L value will be 4,000, F1 18, F0 4, F2 9, and H value is the difference, that is 1000. let's see how to calculate. H value is mentioned 1000, L is 4000, F1 is 18, F2 is 9, and F0 is 4. So just substitute here. L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. So the final answer will become 4000 plus 18 minus 4 by 2 into 18 minus 9 into minus 4 into H is 1000. So after substituting, 18 minus 4 is 14 into 1000 by 18 into 2, 36 minus 13. So 4000 plus 14,000 by 23. Just taking common as 1000, so 1000 into 4 plus 14 by 23, which will become 1000 into 4 plus 14 by 23. Just do your calculation and find the respective decimals. It will become 6087. So final answer will become 4608.7. So in this way, any mode can be calculated using the only one formula, which is L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. So in this way, I conclude the revision of chapter 1 first part, that is mean and mode. For median, I will prepare another video and explain in that chapter. Okay, so what I suggest is, after revising this chapter, if you like the video, please do subscribe for more videos. I just want to explain that I also started MCQ part, where you can check my community and post your respective answer, so that it will be helpful for your examination. Also, if anyone of your friends is having exams on CBSE 10th class, I suggest you to share, so that it will also be helpful for them. Thank you. Let's meet with chapter 13 and the median topic.